Okay, so we look at ionic compounds in electrolysis. Alright, let's have a look at an ionic compound. It's composed of ions, positive ions and negative ions, in what we call a three-dimensional lattice. Here we are. Now you've got to imagine this goes back into the page as well. It's a lattice, okay, and the ions are regularly arranged. Okay, they're stuck in place. So this would be something like sodium chloride, and if this was sodium chloride, the positive ions would be sodium ions and the negative ions would be chloride ions. Now, rule number one, can the ions move? Ions are locked in the lattice. So if they're locked in the lattice, can they move? Obviously no. And if they can't move, you cannot have a current, because the definition of current is a moving charge, and we can't have a moving charge if they're locked. So that's why solid ionic compounds do not conduct electricity. We can do two things to the crystal, the sodium chloride crystal, to make the ions mobile. The first thing we can do is we can heat it up to about 800 degrees C, and the crystal will melt. Okay, and the other thing we can do is we can add water, and the crystal will dissolve. Okay, now what these processes do is very simply they make the ions move around. Now, then we say the ions are mobile. So in this case the ions can't move around, and because of that it's an insulator, it won't conduct electricity. But in these two cases the ions are mobile and it will be able to conduct electricity. Right, let's put some electrodes into this one, and let's put some electrodes into this one. Okay, now in this case what this would be called would be NaCl liquid, and this one would be called NaCl aqueous. So in the NaCl liquid, the positive ions will go to the negative electrode because they're now mobile, and the negative ions will go to the positive electrode. And this, now we say the ions are mobile. Can it carry current? Yes, it allows charge to move through it, so it can have a current. That's why molten ionic compounds conduct electricity. This one is very similar. Ions are mobile again. Will it carry a charge through it? Yeah. Can a current flow through? Yeah, because the ions can move. Same thing here. Positive ions go to the negative. Negative ions go to the positive. The only difference in the water is you'll also have water molecules. Okay, and they'll come into the electrolysis later. So this is a molten system, and this is an aqueous system. Okay, this is known as a melt, and when you add water, this guy here is known as a solution. Now for the melt, we often have to supply heat to keep it molten, and the ions. So that's basically it, and what I'll be doing in the next program is discussing the differences between electrolysing a molten ionic compound and electrolysing an aqueous ionic compound. The major difference obviously is in the molten ionic compound you have only two ions, the positive ion and the negative ion, but in the aqueous ionic compound you have the positive ion and the negative ion from the compound, plus you have these water molecules, and they do affect the electrolysis products. So we'll do that in lesson 2.